Welcome to Graphcore. Thank you for joining us here at our headquarters in Bristol. And today is a day we've been working towards since we started the company 4 years ago. As a company, we've already hit some major milestones. In 2018, we shocked the microprocessor industry and energized the AI community by announcing the first intelligent processing unit, IPU for short. Our team pulled off a huge engineering feat, creating the world's most complex processor, fully programmable, designed from the ground up for just one purpose: to dramatically accelerate machine intelligence. Since then, we've seen innovators in fields such as medical research, finance, automotive, consumer internet, and even quantum physics achieving stunning performance increases. Many are using the latest AI models such as ResNext, EfficientNet, and even sparse natural language processing models, too complex for GPU systems to run well. And they're finding that the more sophisticated the models get, the more Graphcore's technology outperforms the competition. Today, we're moving the industry forward once again, and I'm delighted to introduce Graphcore's second generation IPU. And here it is. But I don't just have one announcement to share. Today, we're announcing 3 breakthrough technologies. The first redefines the standard in AI compute, setting a new benchmark as the world's most advanced processor. The second transforms how data is handled when running cutting-edge AI tasks, closing off the gap between on and off-chip memory. And the third is a new type of high-performance communications fabric that enables IPUs to work together seamlessly at any scale. 3 breakthrough technologies, all delivering on the same vision: to provide the most powerful artificial intelligence compute, seamlessly scaled to any size, built for models that will define tomorrow's AI standards. Let's begin with compute. I'm thrilled to share details with you of Graphcore's second generation Colossus IPU, the GC200. Once again, Graphcore has built the world's most sophisticated microprocessor. Thanks to our partnership with TSMC, we're using the very latest 7nm process, allowing us to fit 59.4 billion transistors onto this one chip. That's more transistors than any other single processor die. As a result, we've been able to put 1,472 independent processor cores inside this IPU. Together, they can run nearly 9,000 separate program threads, all in parallel. Of course, one of the things that helps the Graphcore IPU outperform every other AI technology is that each of the processor cores has its own super fast memory right here inside the chip. In the Mark1, we had a total of 300 megabytes. And with the Colossus Mark2, that has grown more than 3 times to 900 megabytes of memory inside the processor. All of these enhancements taken together mean that our Mark2 based IPU systems deliver more than 8 times the performance of our first generation Mark1 IPU products. In testing, we've seen this dramatic increase across a range of the latest AI models, from image classification, such as EfficientNet, to large NLP systems like BERT Large for training and for inference. So now, let's talk about our second innovation. When you have that much computing power available, you want it to be constantly working for you. Extracting the best possible performance from the IPU means ensuring that those 9,000 parallel program threads are constantly being fed with the right data at the right time. To do that, we've added another powerful new technology. In addition to the ultra-high bandwidth memory inside the IPU, Graphcore systems now have access to large amounts of streaming off-chip memory. Hundreds of gigabytes are available right next to the processor, enough to hold the largest models at the ready. All of this is managed by our Poplar software, which ensures the relevant data is inside the IPU before it's needed. We call this new memory management system Exchange Memory. An Exchange Memory addresses up to 450 gigabytes of memory density with a data bandwidth of over 180 terabytes per second. That's more than 100 times the speed of the latest 7nm GPU-based systems with 10 times the density. These are astonishing performance gains. Nothing else comes close. But at Graphcore, we're doing more than just making the world's best processors. We're also helping people build AI computer systems at data center scale. That means thousands of IPUs working together in parallel. My colleague, Ola Torredbakken, is going to talk about how we're accelerating not only compute, but communication between the devices.
Thanks, Nigel. Welcome to Oslo, where we develop Graphcore's infrastructure and networking systems. We are thrilled to share what we have been working on here over the past 3 years. Anyone who follows AI knows that machine learning models are getting bigger and more complex all the time. We are already seeing in some cases models with hundreds of billions of parameters. This new world of mega models requires many processors working in parallel. And those processors need the fastest possible dedicated fabric, whether you are moving data between two chips on the same board or between racks across the data center. That's why we have created IPU Fabric, or scale-out communication technology, designed from the ground up for machine intelligence. IPU Fabric is an ultra-high-speed, low-latency and low-power interconnect. It uses a 3D ring topology, which maps extremely well to the 3 dimensions of parallelism found in machine intelligence workloads. You can connect up to 64,000 IPUs together in IPU pod systems, with communication performance scaling linearly to several petabits per second. We built IPU Fabric from the ground up because simply AI has a very different set of requirements for communication fabrics. And while this is Graphcore technology, we understand that our customers want to add our systems to their existing data centers. So compatibility with existing infrastructure is crucial. In recognition of this, IPU Fabric can connect to regular 100 gigabit Ethernet switches for rack-to-rack scale-out. This enables direct connections for large clusters of IPUs and adds resiliency and connectivity flexibility. IPU Fabric also enables a flexible disaggregated model, enable users to configure how many IPUs are connected to a CPU through Ethernet, without the constraint of a fixed ratio found in other systems using PCI. Our technology has been co-designed with our Poplar tools. The compiled communication and our use of bulk synchronous parallel compute systems extends to our IPU Fabric, so we get linear scale-up with no communication jitter. Application communication latency remains close to constant as we scale from tens of IPUs to tens of thousands of IPUs. And this co-design of Poplar, IPU Fabric and Exchange Memory makes Poplar able to place models on groups of IPUs and to replicate models across large clusters of IPUs. And because IPU Fabric delivers all of this performance at very low power, more energy is available for compute. We have built IPU Fabric because our customers tell us that they love the power of the IPU and they want the best possible performance as they distribute machine intelligence workloads across different sizes of Graphcore IPU pods. Chip to chip, system to system, rack to rack, IPU Fabric delivers at every level.
Thank you, Ola. You can see the scale of the progress we've made. With our Mark2 IPU, we've once again pushed the boundaries of AI compute. Exchange Memory integrates streaming and in-processor memory more closely than ever before in an AI system. And with IPU Fabric, we've created a communications technology capable of supporting thousands of IPUs working in parallel at data center scale. But we don't just provide these three technologies as separate devices, we've brought them all together in a single industry-changing product. I'd like to introduce the IPU machine. The M2000, as we call it, delivers an IPU engine made up from 4 of our new GC200 IPUs. It delivers an astonishing 1 petaflop of compute. That's a landmark in AI computing. A petaflop in a 1U chassis, less than 5 centimeters tall. It even looks beautiful. Under the hood, we have this amazing airflow system keeping everything cool. You can plug in standard DDR4 DIMMs and have up to 500 gigabytes of DRAM on the board, which thanks to exchange memory works seamlessly with the 3.6 gigabytes of ultra-high bandwidth memory inside the processors. And here's something you might not recognize if you've been using GPU servers with expensive InfiniBand networking cards. With the M2000 and our IPU gateway, the networking is included inside the box. Just slide it into your rack, connect to your data center fabric through a standard Ethernet NIC or your own secure NIC, and connect up the IPU fabric links. You're ready to go. You can connect multiple machines together to make up an IPU pod, or network entire pods together for data center size machine intelligence compute. We're using standard QSFP connectors, so you can use copper or optical connections. And the IPU machine connects to your existing server through your data center fabric. And you can choose how many IPUs you have connected to each server and change these from job to job. Or you can directly attach up to 8 IPU machines to a single server, and the integration is seamless. Poplar will just see what's connected. It's a remarkable piece of technology. Completely modular, totally flexible. You can start with 1 and grow to 1,000. And it costs just $32,450. IPU machine and the associated technologies that we've covered here today are some of the most sophisticated computing tools ever seen. But technological sophistication shouldn't mean difficult to use. One of the keys to Graphcore's success is our incredible Poplar software stack. We've developed Poplar alongside our IPU as a single solution, and our customers tell us that they love its power and its ease of use. In fact, while many people refer to Graphcore as a chip company, we actually think of ourselves as much as a software company. To tell us more about how M2000 works seamlessly with our Poplar SDK, here's Graphcore's Senior Vice President of Software, Matt Files.
Thanks, Nigel. Graphcore's new IPU M2000 enables large-scale data center deployments of our built for AI technology. Users can run vast workloads across up to 64,000 IPUs, acting together as one giant parallel processor. That's 16 exaflops of computing power, petabytes of memory, and supporting models with many billions of parameters. With Poplar, computing on this scale is as simple as using a single machine. Beginning with your model, Poplar works with high-level frameworks including PyTorch, TensorFlow, Onyx, and PaddlePaddle. Whatever your preferred development framework, our graph compiler builds a compute graph to take full advantage of all the technologies we have outlined, including IPU compute, exchange memory, and IPU fabric. Finally, our graph engine builds the runtime to execute your workload across as many IPU machines or pods as you have available. Poplar takes care of all the scaling and all the optimization, allowing you to focus on the model and the results. As well as running big models across large IPU configurations, there may also be times when you want to allow multiple users to run different workloads. So we've made it possible to dynamically share your AI compute between users with Graphcore's virtual IPU software. Perhaps you want to run both training and inference. You can have tens, hundreds, even thousands of IPUs working together on model training. At the same time, you can allocate your remaining M2000 machines to run inference, supporting thousands of users in parallel. These configurations can be changed easily. Because Graphcore technology typically goes into mixed-use data centers, we support industry-standard ecosystem tools for hardware management, including Redfish DTMF, containerization with Docker, and orchestration with Slurm and Kubernetes. And of course, we're adding support for more platforms all the time. For advanced image classification, our Poplar and IPU supports depth-wise separable convolutions and group structures, delivering much higher performance. And a word on sparsity. Lots of research is currently focused on finding ways to take advantage of the sparsity that is inherent in AI models, not just for inference, but also for training. For inference, you can prune the model to reduce compute. The challenge is having a compute platform that can efficiently handle sparse data structures during training. The combination of the Mark2 IPU and Exchange memory system with our extensive library support in Poplar allows the full range of sparsity to be supported in both training and inference. We've also just open sourced our Poplar graph libraries known as PopLibs. This allows the AI developer community to modify its existing functions and to contribute new graph library elements. These are just a few of the ways that Poplar, together with IPU systems, are helping innovators make new breakthroughs.
Thank you so much, Matt. We have such a fantastic set of software tools in Poplar. They really are letting people take full advantage of the Graphcore IPU. Of course, many people making the move to Graphcore products are switching from systems based around graphics processors. It's true that GPUs have improved a lot recently, but I wanted to give you a sense of how much more powerful Graphcore's made for AI technology is. Our system delivers 3 times more arithmetic performance with much higher memory density, and you get 100 times the memory bandwidth, all for very similar costs. Take a state-of-the-art image classification model, EfficientNet B4, and running it on our new M2000 system, it's more than 32 times faster than an NVIDIA V100 GPU-based system. That means, compared to performance figures for the very latest 7nm GPU, our M2000 is still over 16 times faster. To put that in some perspective, 16 of the new DGX A100s would cost you more than $3 million versus just $260,000 for 8 Graphcore M2000s, delivering equivalent performance. It's a huge leap forward for AI compute, made possible by 3 breakthrough technologies: IPU Compute, Exchange Memory, and IPU Fabric, all integrated in a single revolutionary product, our new M2000. Thank you for joining us. We can't wait to see what you do with our amazing machine.